So for this one, it says a person invests $7,000 in a bank. The bank pays 4% interest compounded quarterly. To the nearest tenth of a year, how long must the person leave the money in the bank until it reaches $14,700? Okay, so for this problem, let's take a look at our equation. Actually, I want to pause and see if you guys have ever seen this equation before. Okay, so let's dissect this equation a little bit. This A stands for like how much money you actually want to have in the end. So until it reaches $14,700. So A for amount, 14700. And then the P stands for the principal amount. That's like the starting value. So how much does this person start with? $7,000. So the P, I'm going to replace it with 7,000 in just a second. R is your interest rate in the form of a decimal. So if we have a 4% interest rate, remember to convert a percentage to decimal. You take the dot, so it's 4%, so it's technically 4.0. So decimal's right here. We're going to move it 1, 2 over. So I'm going to put it over here, so it's 0.04. So the interest rate is 0.04. It is the percentage as a decimal, so 0.04. And then it says we are compounding it quarterly. Quarterly means, or compounding is like how many times are you going to calculate the interest for this bank account. If you're compounding quarterly, that means 4 times a year. So that means I'm going to do n is equal to 4. And then n appears twice in our equation, so that 4 is going to appear twice in our equation. So now I'm going to write it out with the actual numbers plugged in instead of just arrows pointing at it. I'm going to write it kind of to the side, I guess, right over here. So 14700 is equal to 7,000. 1 plus 0.04 over 4 to the power of 4t. And t, I'm leaving it as t because it's our unknown. We're going to solve for t. The question was, how long must the person leave the money in the bank? So it sounds like we're looking for t. Okay, so before I do anything to this equation, I've just plugged stuff in. Are there any questions about the plugging in? Okay, so let me zoom out and kind of to the side a bit then, just so I have more space. We're going to simplify the part that's inside here. So literally just, what is 1 plus 0.04 over 4? So on my calculator, what is 0.04 divided by 4? 0.01. So this is 1 plus 0.01 to the power of 4t. And let's simplify that again. Okay, so I've just simplified the part inside the parentheses until it got to just one number instead of a number plus a fraction, instead of 2 numbers. So from here, we want to get our exponential by itself, just like in the last section. We want to get our exponential by itself. So what is our exponential? This entire piece is our exponential. Once we get this highlighted piece by itself, then we can apply the log. So in order to get that highlighted portion by itself, what we want to do is divide both sides by 7,000. So that way, these can cancel out. And then whatever that is on the left side, I'm going to type it into a calculator. 14700 divided by 7,000. Okay, and I'm going to continue writing up here because I have space up here. So when I divided 14,700 by 7,000, I got 2.1. And then on the right side, I got, that's not the right number. On the right side, I got 1.01 to the power of 4t. Okay, before going on here, are there any questions? Okay, so at this point, we have now gotten our exponential by itself. It's kind of like the last category. So once you get your exponential by itself, this is good news because now you can apply the log to both sides. And so we apply the log to both sides so that we can get the exponent out of the, we can get this out of the exponent. So literally just write log in front. So I just wrote log in front of both sides. And now that we're taking a log of this thing, we can move the 4t to the front. So it's 4t times log 1.01. So the log helps us get the 4t out of the exponent and just into the front. So now we have log 2.1 is equal to 4t log 1.01. Okay, and once we get this part, we can divide both sides by log 1.01. Divide by log 1.01. This will cancel out. We will have it equal to 4t. And here is where I should have kept the calculator up and open. So let me see if I can do it on my phone. We have log 2.1 divided by log 1.01. Okay, so log 2.1 according to my phone's calculator is 0.3222219. I'm just going to kind of round it. And then log 1.01 on my calculator is 0.004321. So when I divide both of these, I get 0.322219 divided by 0.004321. I get 74.570 is equal to 4t. Okay. Pausing here, are there any questions? All right, so now that we know 4t is equal to this, the last thing we need to do is just divide by 4. So on my calculator on my phone, divide by 4, and I get 18.64 is equal to t. Okay, and so this is how many years, oh, to the nearest tenth of a year, my bad. So not the nearest hundredth anymore, nearest tenth, so I should actually write 18.6. So the tenth is 1 decimal place. So this is the final answer that I'm going to type into Delta Math. Before I type it in, are there any questions? All right, let's go ahead and type this in. 18.6. Okay, so let's do another one. So we have another investment problem. A person invests $3,000 in a bank. This is your starting value. So that number, that principal amount is $3,000. The bank pays 4.25 interest compounded semi-annually. So let's kind of dissect what that means. The 4.25, we're going to have to convert this into decimal form. So right now it's in percentage. To convert it to decimal, you move it 2 over. I'm going to put a 0 there. So this is actually 0.0425 now. So this is your R. $0.0425, yes. And then compounded semi-annually, I believe that means twice in the year. So semi-annually, if that's twice in the year, that means your N is equal to 2. N is how many times are they going to calculate your interest in the year? So if it says semi-annually, I believe that is 2. And then to the nearest tenth of a year, how long must the person leave the money in the bank until it reaches 5,600? So that is the amount that we want, 5,600. Okay, so I've kind of pointed at everything. Oh no, I haven't put it at N. we said that our n would be 2. So now that I've pointed at everything, let's rewrite this with actual numbers, and we can actually replace all of those arrows. So we have 5,600 is equal to 3,000 parentheses 1 plus 0.0425 divided by 2 to the power of 2t. And remember, t is left there as a letter because it's the unknown that we are searching for. So we are looking for the nearest tenth of a year. How long must the person leave the money in the bank until it reaches that amount? So that's why we are looking for t. So t is still our unknown. Okay, so before we proceed, we must make those two numbers, combine them into 1. So whatever 1 plus 0.0425 divided by 2 is, let's figure that out. So on my calculator, I get 0.0425 divided by 2. Okay, and then combine again. (1.02125) to the power of 2t. Okay, so here's our simplified starting formula. Now, we must try to get our exponential by itself. So the exponential is the 1.02125 to the power of 2t. We want to get that by itself, so to do that, we're going to divide by 3,000 on both sides. And I'm going to scoot out a little bit so I have space over here to write it out. So what is 5,600 divided by 3,000? I'm just gonna leave it as a fraction. No, it's okay. I'll round it. 1.866. Yeah, I think that should be enough decimal places. The 6 is just repeating. Here, 1.86 repeating. That is the 5,600 divided by 3,000. And then on the right side, the 3,000s cancel out. We have our exponential by itself, 1.02125 to the power of 2t. So now we have the 2t as our exponent. And so remember, when you want to get it out of the exponent, we're going to just write log in front of both sides. So we're going to take log of both of these. So log of 1.86 repeating is equal to log of 1.02125 to the power of 2t. So we take the log of both sides. And when you do a log of an exponential, this exponent gets moved to the front. So 2t log 1.02, I'm writing that wrong, 1.02125. Okay. So we just took that 2t as the exponent and moved it to the front. And then, now we can divide both sides by that log of 1.02125. Log 1.02125. That way these can cancel out and we can finally just get 2t all by itself. And on the left side, here's where I have to type into my long calculator on my phone. So log of 1.86 repeating, let's see what that is. That gives me 0.2710667. Okay, let me just make sure I wrote that right before I keep going. 37, 10, 66. Okay, and then on the bottom we have log of 1.02125, and I get 0.0091320695. Okay, so I'm going to divide both of those two numbers. 0.27106677 divided by 0.00931320695. Okay, and I get 29.683 is equal to 2t. Typing that on my phone takes a lot longer, I'm sorry. But luckily you guys have the Delta Math calculator. And then you just divide by 2 on both sides. 2's cancel out. You get t is equal to 14.8. And remember, we are rounding to the nearest tenth of a year, so I'm just going to leave it as 14.8. Are there any questions for this one? You guys really don't have questions today, huh? Okay, so there's another type of problem on these. So let me see if I can find them. I'm going to give up on this. Okay, so there's another type of problem that's radioactive decay, and that's what I was looking for. So here, we found it. Element X decays radioactively with a half-life of 10 minutes. If there are 760 grams of element X, how long to the nearest tenth of a minute would it take the element to decay to 39 grams? So earlier we were talking about exponential growth. Now we are talking about exponential decay, which means it's going to be like the amount of this radioactive element will be cut in half after a certain amount of time. So it's like there's going to be less and less of this radioactive element, whereas in the last problem, we were talking about interest, so you get more and more money. So this one's a shrinking amount. And so if you look at our equation, this 0.5 here, it's a 0.5 because we are talking about half-life. Okay, so that's why it's a 0.5, because 0.5 is half, and every certain amount of time, the amount of the element is going to be cut in half. Okay, so if there are 760 grams of element X, that's going to be right over here. That's your starting amount. And then how long to the nearest tenth of a minute would it take for the element to decay to 39 grams? So 39 grams is your Y value. It's what you want it to end up as. So it's pretty similar to the last problem in many ways. And then also your half-life is 10 minutes. So that is the H for half-life. So you're going to put the 10 over here. And once again, T is left as T because it's our unknown. We're going to find T. We're going to solve for T. So I'm going to rewrite everything. So we have 39 is equal to 760 times 0.5 to the power of T divided by 10. Okay, any questions up till here? All right, so the process is pretty much the same. You just want to get our exponential by itself. So the exponential being that bit. And so we're going to divide both sides by 760. And so this is going to be, I'm just going to leave it as a fraction. 39 over 760 is equal to 0.5 to the power of T over 10. So now we have our exponential by itself, 0.5 to the power of T over 10. And once you have your exponential by itself, you can do a log of both sides. So I'm just going to write log in front of both sides. So log of 39 over 760 is equal to log of 0.5 to the power of T over 10. Oops, I'm trying to zoom out. So remember, once you get your log of an exponential, that exponent gets moved to the front. So I'm just going to rewrite that up here because it's where I have space. So the left side still stays as log of 39 over 760. On the right side, I'm going to take that exponent, that T over 10, I'm going to move it to the front, and then it's log of 0.5. Okay, so from here, we can divide both sides by log of 0.5. Those can cancel out. We will have T over 10 on the right side. Sorry, that is a T, a very ugly T. Okay, so we have t over 10 on the right side, and on the left side, we can type that into a calculator. So whatever log of 39 over 760 divided by log 0.5 is. And so this time, instead of doing it on my phone's calculator, I'm going to pull up Delta Math on my computer, and I will type it in there. So I just typed it in, I got that amount. And so this is equal to t divided by 10. So once again, to get t by itself, you need to get rid of that 10. So this is t divided by 10. I'm going to multiply by 10 so that I can cancel out that. Because dividing by 10 will cancel out with multiplying by 10. And this will give us 42.844 is equal to t. Now we want to round it to the nearest tenth of a minute, so it will be 42.8 minutes is equal to t. So I'm going to go ahead and type 42.8 into the Delta Math, but before I do, are there any questions? 42.8. Oops, 0.8. All right, let's do another radioactive decay one, but of course, if you don't need the extra help, then you could be working already. All right, so I just skipped the problem. Now we found another radioactive decay. So we have element X decays radioactively with a half-life of 13 minutes. So this half-life is going to be our H value. So I'm going to replace that with 13. If there are 830 grams of element X, so this is your starting value. So your starting value goes over here, 830. How long to the nearest tenth of a minute? So we're looking for T. Would it take the element to decay to 20 grams? So 20 is what we want. So we put it on this side. I'm going to rewrite everything now instead of just arrows. So 20 is equal to 830 times 0.5 to the power of t over 13. So I plugged everything in. Now we can solve by first getting our exponential by itself. So our exponential is this bit. So I want to get rid of that 830. So I'm going to divide everything by 830. And so we are left with, I'm just going to keep it as a fraction because I'm going to type it into the calculator later. Anyways, so 20 over 830 on the left side. On the right side, these cancel out. And we get 0.5 to the power of t over 13. So our exponential is by itself. And once your exponential is by itself, here's when you can apply the log to both sides. So I'm just going to write log in front of both of these. So log takes in the 20 over 830, and then a log over here of 0.5 to the power of t over 13. I'm going to zoom out because I'm running out of space. So now that we have a log of an exponential, take that exponent and we're going to shove it into the front. So let's continue over here. Log of 20 over 830 is equal to, now we take that t over 13 and we're going to move it to the front. So t over 13 times log of 0.5. So all we did here was take that exponent and move it to the front of the log. And you can do this when you take a log of an exponential. Okay, so then we're just going to divide by log of 0.5 on both sides. This canceled out. We will be left with t over 13 on the right side. And on the left side, let me go and type it into a calculator. So now that we got that amount, this is equal to t over 13, so t divided by 13. To cancel dividing by 13, I'm going to multiply by 13. And that will give me, now I'm going to use my phone calculator, 5.375039 times 13. 69.87 is equal to t. Okay, and we're going to round it to the nearest tenth of a minute, so it's 69.9. Why did that disappear? 69.9 is equal to t. So that's the answer I'm going to type into the calculator, not calculator. That's the answer I'm going to type into Delta Math. Are there any questions on this problem? Okay. And cool. So I know that was a long lesson, but it was brand new stuff. So that's why I wanted to do more examples of each of these. So hopefully that was enough. If not, call me over to your breakout room.